Good afternoon, flippers. This is video 3.14. You're so excited. The last video in this particular unit, Rooftop Triangles is the title, and your objective is students will be able to use inequalities, that's right, they're back, to find sides of triangles. And your IXL skill is Q3. All right, so let's go, flippers. So the first thing we want to talk about today really is just this idea that if you have two triangle, like we have here, triangle A, B, C. So if you have a triangle and it has measurements, here's 3, this segment is 5, and this segment is 7. What happens when you have triangles with side lengths already given, you can also talk about the measures of those angles and how big they are. So for example, angle C is 100 degrees here, and its side that's opposite angle C is 7. Angle A is 30 degrees here, and its side that's opposite is 3. And then angle B, which is 50 degrees, its angle opposite, the side opposite that angle is 5. You'll notice that there's a relationship here. And the relationship is that the largest angle, which would be angle C, is across from the largest side, which is side AB. So this is true for all triangles, okay? So let's actually write that as a statement. And that statement would be the largest angle is across from the largest side. And this is also going to be true for the middle angle. So I'm just going to write middle angle. And then for the smallest angle too. Okay, and I'll just put quotes, meaning it's basically the same thing. So you don't have to rewrite it, write it again. Okay, so again, remember, the largest angle is across from the largest side, hence angle C is across from side AB, which is the longest side. The middle angle is across from the side that's in the middle, and then the small angle is across from the smallest side length. And when I say middle angle is across from the middle, I mean the segment that has the, not the largest or the smallest, but the side that is in the middle length. So we talked about that because that actually is an inequality in itself as well. So we're going to talk about the triangle inequality theorem today. And the triangle inequality theorem is really kind of cool. And it says that the sum of the lengths of any two sides of a triangle is greater than the length of the third side. We have a triangle, again, triangle ABC, and we're going to actually write down what this theorem would actually say out in words for each side. So if I were to take side AC and I were to add it to side CB, we're saying that this theorem says that these two sides, when we add them together, have to be greater than AB. So let's test this out. So AC is 5, CB is 3, and we're saying that has to be greater than AB, which is 7. Hey, that's true because 8 is greater than 7. All right, so it worked for one. All right, so let's try one. Let's try two more. So let's take side CB, and let's take side AB, and add them together, and we'll see if it's greater than side AC. Okay, so then CB is 3, AB is 7, remember from earlier. And is that greater than the other side, which is 5? Hey, that's true. 10 is greater than 5, so that works for the second one. And our AB. And then we have to take AC because we haven't added those two together yet. And we want to see if that's greater than CB. Okay, so AB is 7, AC is 5. And is that greater than this side, which is CB over there, is 3? It is. 12 is greater than 3. So that's what this theorem is really saying. It's saying, hey, I can take any two sides, and it's going to be greater than that third side. Okay, and we just actually proved that that's true by using all three side lengths and combining them in all the possible ways to show that it worked out. So this is a true theorem. Okay, all right, so let's take a look at another inequality that we will have to look at, and that was our first one. So the second inequality that we're going to look at is actually 3 particular statements. 2 of them are inequalities and 1 is an actual equation that you will recognize. Okay? And the first one that we're going to talk about, let's just talk about this statement. So it says, if A, B, and C are the side lengths of a triangle. Okay? So we're already stating that. And we're also saying that A, B, and C here, where C is the largest, B is in between, and A is the smallest. So basically this means that if you are given 3 segments, A, B, and C, and they are not in order from least to greatest, you need to put them in order from least to greatest before you start this problem. Okay? All right. So now it says A squared, here we have, plus B squared is going to be greater than C squared. If this is true, young people, if this happens, then that means this triangle is acute. That's right. You can actually classify a triangle this way. It's a secret. I haven't told you it yet, but it is true. Okay? Now, the second one, you probably already know the answer, right? Because we are classifying types of triangles right now based on inequalities. So the second one says, well, wait a minute. The second one's not exactly an inequality. It's an equal sign, so it's actually an equation. A squared plus B squared equals C squared. If this is true, it is a right triangle. And most of you knew that already. And the final one says A squared plus B squared. If that is less than C squared, then this is an obtuse triangle. So that is really, really powerful. And we're going to play around with it right now. Here's question number 1. It says, which of the following could represent the sides of a triangle? So we actually have to test all 3 to see which one works. We're going to start with the first one. All right, so here we go. We're going to go 1 plus 2. Is that actually greater than 3? Remember, it has to work for all combinations. So when we test this, we get 3 is actually not greater than 3. This is false. So this set cannot work at all. Once you hit a roadblock, like this, you have to just move on because it did not work. It will have to be greater than. It has to be true that when you add 2 of the legs, it has to be greater than the third leg. So let's move to the second one. So we've got 6 plus 8. Is that greater than 15? 14. Oh, nope, this is false too. That's not greater than 15. So this is also wrong. Oh my gosh, we only have one choice left. But let's just make sure it works, okay? So we've got 5 plus 7. Is that greater than 9? It is. 12 is greater than 9. And then we have to combine it the other 2 ways. Let's just make sure it works. So then we're going to take 7 plus 9. Is that greater than 5? It is. That worked. And then the last combination, we already used 5 and 7. We already used 7 and 9. Now we use 5 and 9. Is 5 and 9 greater than 7? It is. So this actually works because all of these are true. True and true. So this is our answer. Question says, in triangle ABC, if the measure of angle A is 30 and the measure of angle B is 50, which is the longest side of the triangle? Please draw the triangle. To start drawing this triangle, you have to be thinking about something. 2 of these angles are really, really small, and the other one is going to be bigger than 90, right? Because they all add up to 180. Remember that. So that's why I drew it this way. So triangle ABC, this is going to be my A. It's going to be my B. And that angle that's bigger than 90 will be C. Okay? So now they're asking me what's the longest side of the triangle. I know that this angle is the biggest angle. And I know that across from the biggest angle is the biggest side. Boom! So it's going to be AB. And most of you could probably visualize that, but you need to draw the triangle. It helps you get the answer right. All right, let's look at question number 3. Number 3 says, the sides of a triangle have lengths 3, 7, 9. What kind of triangle is it? All right, so here we go. We're going to test and see which one it is. And this is what your IXL skill will look like. So you just want to knock it out this week. So let's try it. So we've got 3 plus 7. We want to see what happens when we add that. Oh, wait a minute. 3, 7, 9. We got to make sure that they're in order from least to greatest. 3, 7, 9. They're in order from least to greatest, so we are ready to start. So 3 plus 7. Is that greater than? Is that equal to? Or is that less than 9? So let's see. It happens to be greater than 9. So that means this is going to be, you guessed it, an acute triangle, which should make sense. Should really make sense because 2 of these sides are going to be small, right? Smaller than 90 as far as the angles that are opposite from them. And then one is going to be acute. Very similar to the triangle we just drew in question number 2. Here is your secret hot question for tonight. The sides of a triangle have lengths 4, 4, and 6. What kind of triangle is it? Acute, right, or obtuse? Show your work and do your Excel. Have a great weekend.